Hello, everybody. My name is RDvries, and I'm professor from the Universidad Santiago de Cali in Colombia. And I want to introduce my work entitled Synthesis and Characterization of Metallodrugs with Potential Use for Overweight Treatment. About 100 million people worldwide have type 2 diabetes, making it one of the most common chronic diseases. Diabetes is characterized by the high concentration of glucose in the blood due to excessive production of liver glucose and resistance to peripheral insulin. Currently, the underlying causes of the physiological behaviors are not well understood, but diabetes is known to be associated with both genetic and acquired factors, such as unhealthy eating habits, stress, hypertension, obesity, sedentary lifestyle, and metabolic syndrome. Metallodrugs are pharmacological compounds that contain an organic molecule coordinated to a metallic center. In this sense, different metallodrugs complexes from metformin are obtained and tested its biological activity against different microorganisms. This work focuses on the synthesis, characterization, and structural study of complexes based on metformin and transition metals, including cobalt, copper, nickel, and zinc. We aim to make a first close-up to the cytotoxicity activity in order to propose new therapeutic alternatives in the treatment of diabetes and metabolic syndrome. The obtained compounds were characterized by powder and single crystal X-ray diffraction, infrared and UV spectroscopy, thermogravimetric and differential scanning calorimetry, physiochemical analysis, optic microscopy, and cytotoxicity tests. The obtained compounds were obtained by classic method of reflux, using the metformin as ligand and the 4-metal as metallic centers. From that, 4 new compounds were obtained. The first compound, the cobalt compound, was obtained as cubic reddish crystals that crystallize in the C2/C monoclinic space group with 1 molecule of the cation complex, 2 chloride anions, and 1 molecule of water in the asymmetric unit. The cationic complex is present as a 6-coordinated arrangement, generating a distorted octahedral polyhedron formed by 3 molecules of metformin in the chelate mode. The second compound, the compound of nickel, was obtained as yellow crystals that crystallize in the P21/C monoclinic space group. The compound contains 2 cationic complexes, 2 chloride anions, and 2 water molecules in the asymmetric unit. The complexes are formed by 1 metformin ligand and 1 deprotonate metformin ligand coordinate to the nickel center, forming a 4-coordinate arrangement with a distorted square planar polyhedron. The third compound, the copper compound, was obtained as purple crystal, as previously reported by Lemoyne. The asymmetric unit is formed by a half of copper metallic cation located in a symmetric center, which is coordinated by 1 chelate metformin ligand, 1 chloride anion has a counter ion, and 1 free water molecule. The complex is formed by the coordination of 2 chelate metformin ligand to generate a 4-coordinate rectangular polyhedron. Finally, the compound 4, or zinc compound, was obtained as colorless crystal. This compound was previously reported by Su, with 1 zinc metal coordinated by 3 chloride anions and 1 protonate metformin molecule in the asymmetric unit. The final complex presents a tetrahedral arrangement around the zinc center. To understand the supramolecular behavior of the obtained compounds, Hirschfeld surface and fingerprint plot analysis were performed. It is possible to observe in the Hirschfeld surface that the red regions are located on the donor-acceptor amine and imine groups. The fingerprint plots quantify the contribution of each interaction to the crystal packing. It is possible to observe that in all the cases, the strongest and most important contribution to the crystal packing is given for nitrogen-hydrogen, oxygen-hydrogen, and hydrogen chloride interaction, characterized by the presence of narrow peaks in the bottom of the fingerprint plots. We observe important interaction, including carbon-hydrogen and hydrogen-hydrogen, where the hydrogen-hydrogen interaction are the more abundant interaction in the crystal packet. Only in the zinc complex, we observe a high contribution of the hydrogen chloride interaction in the formation of the crystal packet. Finally, C2-C12 cell lines, that is a muscle cell of the mouse, and HIP-G2 is a human liver carcinoma cells, are widely used in the evaluation of the potential activity of the new molecules with antidiabetic activity or different metabolic activity. They are in vitro models that give preliminary information on the activity of specific molecules in reversing metabolic abnormalities in organs and or tissues involved in the establishment of diabetes. The present results shows the compounds 1 to 3 exhibit low cytotoxicity at concentration below 62.5 micrograms per milliliter and a high concentration, 1000 micrograms per milliliter. The cell viability is reduced in some cases around 50% in both cell lines. Finally, the molecules present in this work was patented in the United States Patent and Trademark Office with a temporary patent and are in process to patent in the European Union and the United States. For more information, you can send me an email or download the paper. Thank you very much.